Hello and welcome. We are excited that you will join us. Come on, let's learn.
We sometimes say decimal when we mean anything to do with our numbering system, but a decimal number usually means there is a decimal point. Commonly speaking, we talk about decimals when numbers include a decimal point to represent a whole number plus a fraction of a whole number. We can classify decimals as terminating and non-terminating. Non-terminating decimals can be repeating or non-repeating decimals.
Before going on, let me ask you, what is terminating decimal? To answer the question, terminating decimals are those numbers which come to an end after few repetitions. For example, we can express 1/2 into decimal by dividing the numerator by denominator. We have 1 divided by 2 is equals to 0. 0 times 2 is 0. Then 1 minus 0 equals 1, bring down 0. 10 divided by 2 is 5, multiplied by 2 is equals to 10. And 10 minus 10 is 0. The process comes to an end or finished. It means that 5/10 is finite number of digits after the decimal point.
Another example. The value of 125 thousandths in fraction form is 1/8 because 1 divided by 8 is 125 thousandths. The digits after decimal point was terminated or stopped.
Let's move on. Now, what are non-terminating decimals? Non-terminating decimals are those which keep on continuing after decimal point. They don't come to an end, or if they do, it is after a long interval. First, look at the examples. Whereas, these are the ones that do not have an end term. It has infinite number of digits after the decimal point. It does not stop and repeating. Now, let us proceed to repeating decimals. When do we say that a decimal is repeating? Suppose we are building a bridge to go over a river. When we try to calculate how long the bridge needs to be, we end up with a decimal number, for example, 14 and 333 and so on. For each decimal place, we end up with the number 3 and recognize that this pattern will continue indefinitely, and it is repeating decimal. And what are these numbers? Repeating decimals are numbers that eventually takes on repeating pattern of digits after its decimal point that will continue forever. We represent this by using 3 periods at the end of the number, like with 14 and 333 thousandths. You can also indicate repeating digits by writing a bar over them.
The following are examples of repeating decimals. Notice that for each of these numbers, the digits after the decimal point eventually take on a repeating pattern. In example A, we see that the repeating pattern of digits is 5-3 and it is indicated by drawing a bar over it. In example B, the repeating pattern of digits is 7-5-2, while in example C, the repeating pattern of digits is just 3. No matter how many times we perform the calculation, these patterns will continue on indefinitely.
Hey there, this is where this video ends. Hope that you learned with fun. Thank you.